ultimately, our goal is to find data and features and predictions in as many places as we can, right? Essentially collecting data historically. Then what I can do is I can go back in time, and for every day I can see what the world looked like on that day, and I can use it to see what happened to that company over the next week, month, year, whatever. Maybe I'm going to end up using that as a trading signal eventually and build what we call a model, which is basically something that takes data in and makes predictions about future prices of the assets we trade.
All right, everyone. Welcome to another episode of the TWIML AI podcast. I am your host, Sam Charrington. Today, I'm joined by Ben Wellington. Ben is Deputy Head of Feature Forecasting at 2Sigma. Before we get going, be sure to take a moment to hit that subscribe button wherever you're listening to today's show. Ben, welcome to the podcast.
Thanks. It's nice to be here.
It's great to have you on the show. I'm looking forward to digging into our conversation. We're going to be chatting a little bit about how LLMs and GenAI are changing the way you approach problem solving there. To get us started, I'd love to have you share a little bit about your background.
Sure. Yeah. My background is in natural language processing. That's anything having to do with computers interacting with human languages. And I like to say I got into it before it was cool, back before Siri, it just sounded neat when I read a description on NYU's website of a research area. So I didn't realize that I was stepping into this large part of the future, but hence that's what I
Here
did.
we are.
Here we are on this podcast, right? I mean, who would have guessed? Um, so I did my PhD in machine translation, and it was a different time back then in this space. Looking back, there was this tension between empirical natural language processing, which is like, if we have enough data, we can solve all of our problems. And then sort of the more syntactic approach. No. We need to understand noun phrases and verb phrases. Even so much in the 90s, right? UPenn hired a bunch of grad students to draw sentence tree diagrams to make the Penn tree bank, which was like the preeminent data set. I mean, if you were in natural language processing in that period, you knew the Penn tree bank, right? That was, and you slept thinking of verb phrases and adjectives, and you had nightmares. And so it was a cool time, and there was this tension: how much do we really need to know about language to sound like we're speaking language, right? Do we understand the depth of syntax, or can we just go the data route? And I think, looking back, the data route clearly won out, and we can talk about that journey today. But it's definitely been interesting.
Tell me a little bit about your journey to and at 2Sigma. Your title is Deputy Head of Future. Sorry, I keep saying future forecasting. Feature forecasting. What is feature forecasting there?
So at 2Sigma, we're an investment manager, and ultimately we're trying to invest in instruments that we trade, and to do that, we want to predict the future price of things, right? So to do that, we have to kind of, whether it's a company or a currency, right? We have to understand a lot of information about, say, a stock, let's say, IBM, and use all that information to make predictions about the value of that company. And to do that, we think of this breaking down. We think of breaking down the world into features, where a feature is just sort of a interesting, observable fact of interest about something. We have philosophical debates about what is a feature, and so the idea is that for a company like IBM, there are thousands, tens of thousands, maybe millions of features that might tell you about it, right? It's sales numbers, the number of computers, the people who work there, where they came from, the board, the stock market prices. And for each of those, if we can quantify them, if we can measure them and record them, then we can use them to predict what happens next. And so this idea of feature forecasting is to make a lot of interesting features about the world, and then use those features to forecast about what's going to happen in the world.
So this reminds me of I don't remember when we started doing this, but we, the royal we, I guess, but like the we're going to take satellite imagery as it passes over Walmart and count the number of cars in the parking lot and use that to predict share price, that kind of thing. That would be an example of a feature, which is like,
The number of cars in the parking lot at any given hour would be a feature for sure, right? That's a very interesting feature you could get from a satellite image. That's a great example.
and it sounds like it's maybe correlated, you could say, with the way we use feature for in the context of a machine learning model, but it's not necessarily like it's more like an abstract idea. But they end up being machine learning model features. Like,
It's highly correlated. I mean, we think the term probably derives from our use of machine learning on all of this data. So it's not just correlated. I mean, it's probably accurate to say that's the connection. That ultimately you can do a lot of things. I mean, I can take that satellite example you just said and do something very simple with it, and which is to say, all right, well, I see 30% increase in cars in the parking lot, so I'm going to predict 30% increase in sales. That's not machine learning. It might be if you use machine learning to extract the car count from to make your feature, right? But ultimately, that feature is going into some linear math that's quite simple, but it's still a feature, right? And another way you would do it would be to combine that with thousands of other pieces of information into a neural network. And then it's truly a feature in the sense that you're referring to. So yeah, I mean, there's a lot of overlap.
I want to kind of understand, like, how maybe even like a day in the life of like a feature forecaster. Like, how do you go about the role, or how do you think about the prototypical workflow that you're working on?
Ultimately, our goal is to find data and features and predictions in as many places as we can, right? So what does a day in the life look like? I don't know. You're walking by a Target and you see a help wanted sign in the window, and then you say, oh, I didn't know they're hiring here. That they're interesting. That's growing. And then you say, oh, well, maybe that means they're doing well. And then you say, oh, well, can I measure employee hiring across all companies that we trade? Well, how would I do that? Okay. And you do a bunch of sort of, and then following this sort of inquisitive detective style work until you might say, okay, hey, look, companies post job postings on their websites. So I can start to collect that data. And if I can analyze it, I can start to create features about open roles for every company. Once I do that, it's not that complicated to think about, all right, I have all this data. What are some hypotheses that might come out of hiring? Is there an increase in hiring seasonally since last year? Do we see this movement? And uh, what we tend to do is start with a hypothesis. We test that hypothesis by essentially collecting data historically. So not only do I need the job, this is the hard part. Not only do I need the job postings there today, but in theory, I need historical views of those job postings. And so let's pretend for a second that I have 20 years of companies' job postings, which is hard to build, but let's just give me that. Then what I can do is I can go back in time. And for every day, I can see what the world looked like on that day. And I can use it to see what happened to that company over the next week, month, year, whatever. And so I can test my hypothesis. Hey, is it true that an increase in job postings leads to an increase in share price? And it's just a scientific statistical test. If the answer is yes, maybe I'm going to end up using that as a trading signal eventually and build what we call a model, which is basically something that takes data in and makes predictions about future prices of the assets we trade. And that 20-year, I can't stress enough, where do you find 20 years of history on a company's website? That is the interesting, challenging part about this work is timestamps are so crucial. We typically, in order to get 20 years of data, a lot of the time you have to say, okay, let me start recording this and I'll come back to it 20 years later, which is a very forward
So in
thinking way
3 years, you'll be able to do your job.
right. Right, exactly. So, obviously 20 years is a big, but maybe there are many things that I've been recording for 5, 6, 7, 8, 10 years that we're now able to do, or even 15, right? So you have to have, people used to ask me, hey, what data should you be recording? What should we record? And the answer was always anything that might be interesting in the future. I don't care if it's interesting now. It's like, this is a time capsule. If you hit record today, this is a gift to either you in the future or another researcher at the firm who's going to suddenly have this rich history of data to then go and study. Because if you don't have that historical data, a lot of data just disappears like forever. There's no recording of it. There's a great example, which is we worked with a newswire, and they would send us news stories about companies. And one day we get this call, hey, uh, I heard you have a recording of our news. Can we buy that from you? Because a news company, they don't mind rewriting their headlines. They don't mind changing, adding little topics, editing. And so they don't actually know at noon on this day what they actually had sent. They only knew the edited version. And so we kind of had this beautiful real-time history of the world that many people didn't start recording, in the early days of the company. People didn't really realize how important recorded history was.
I've got to imagine that the hard part of that, what should we record or what should we save, is really what shouldn't we save?
Yeah, that's true. I think today there is what shouldn't we record, and obviously there's legal issues that you have to clearance to record something, and so there are things that would prevent you from recording for various reasons. But in terms of things that are open to the public and available, if you think it might be interesting, maybe kind of sort of like let's record it and then figure it out later. Don't worry, just make sure you have access to the rawest data possible, because the more you analyze it and throw out the raw data, the less useful it will be in the future if someone wants to do something different.
You talked about the walking down the street, seeing Target, sign. That's very organic scenario, but I've got to imagine at the scale you're operating at, you're being approached constantly by companies trying to sell you data that they've already collected. Like, how much of your job is trying to figure out these organic sources versus, parsing, trying to find the needle in the haystack of all the crap that people are trying to sell you?
I would say when I started the company, it was mostly things we recorded, right? Because people didn't even realize that this was a product that they could sell.
Data
We
wasn't
people
the
would
new
say,
oil yet.
right. And so you'd have a social media monitoring company who's used to selling Coke mentions to Coke and Pepsi mentions to Pepsi. And they say, well, what company do you want to track? And we said, all of them. And they say, wait, what? And we're like, all of them. They're like, that's not one of the options. We're like, well, then that's not helpful. So as people started to realize, oh, wait, there's value in a holistic view of all the companies that we're looking at once, products started to emerge, and big financial companies have since then created a lot of products over time. So I think you're right. In the early days, it was really about recording and just having that asset. Today, there is a lot of incoming stuff. People are trying to sell you on different products, and um, I think needle in a haystack is a good way to think of it. I mean, some of it is going to be valuable and innovative, and you have to use your priors. What's novel here? How is this different? What's the edge? To try to decide what you want to spend your research time studying, right? I want to study everything. I just have limited resources, so I have to pick and choose, and that's what makes a good researcher. Somebody who has a nose for where to look for the next great idea.
You referenced earlier the idea that the closer you get to the raw data, the raw capture, the more valuable that data is. But I also imagine that, there is a hierarchy of features and like derivative features and that kind of thing. Like, how do you think about all that? Like, are you trying to do that? Well, first of all, is your team focused on derivative features, or do you just hand data over to modeling teams and they generate whatever derivative features they want? And like, how does that all come together there?
Our team actually is also a modeling team, so we're both creating the features, but then also making predictions off them end to end. There are other teams that focus a little bit more on more differentiated techniques in machine learning that tend to take the features we create as inputs. But we do tend to do end to end work. In terms of the hierarchy, it's a great point. So when I said raw data is useful, I meant in the sense that if you have raw data, you can create any of those derived features in the future. Whereas if you deleted your raw data and you made derived features, and then you had a new idea, sorry, your idea, right? A great example would be you could look on television stations and you could record the words being said and then throw out the videos. And then one day you have technology to look at videos, but it's too late, right? Whereas if you recorded the actual videos, then that's waiting for you as a future creation and avenue. On your hierarchy point, yes, absolutely. Raw data is useful because it can create more things, but it's not useful in the sense that if you have 25 people that want to use your data, giving them a pile of raw bytes is probably not the most effective way to get them to use it effectively, right? I talked about, I don't know, looking at television stations. Let's look at an example of, I don't know, a CEO being interviewed on CNBC. Um, as an example. So I could just say, all right, everybody here's access to a video that we have and be done. And everyone, or I could say, yeah, not much of a feature, right? It's the ultimate mega feature. Yeah, it's not a good feature. And so then the question is, well, what are the features that you would want to create and share and pass on from that? And that's where the job gets really exciting. I mean, you asked sort of what the day in the life of our job is. I think the most exciting thing is to convert that data into hypothesis-driven ideas. Examples might be
The number of times they touch their nose, is that a feature?
exactly right. So
Are
now,
you literally capturing that?
well, if I'm not, I can go back and add it, right? Because I have the raw data. So that's the idea. It's like any idea you have, you could go back. We could talk about how we would do that in a bit. But any interesting, how many times they're blinking, are they smiling, right? There's obviously the words being said, which have a lot of value. But if you want to get even more wild, you could look at other things. How many questions were they asked? And you could even take a baseline of a CEO. The last 10 times they were on, they were X. What is, the number of times
It's the moving average of their nose touches.
touch their nose is 5, like red alert. Uh, and I'm only half joking, right? Because it is possible that nose touching is nerves, and that when someone is more nervous, there's something else happening, and thus you could. And so if I believed in that, if I did, I could spend my time, I could make that feature, and I could go study, assuming I had history, a lot of assumptions, and I could say, all right, let's take 20 years of these interviews, let's count nose touching, and let's go study it. And any one of those things could be like a cool PhD thesis. But there's a lot to do, and so we're off. We're not going to that depth at all times. But those are the kind of ideas that we love to chase.
Ultimately want to dig into like how the way you approach the, you know, capturing these features and analyzing and modeling off of these features has evolved with Gen AI. But um, maybe before we do that is a good time to talk about how you might go back and pull out these new features.
Maybe I want to say, is the person talking about the future or the past in these interviews? Interesting feature, right? What percent of their conversation is forward looking versus backwards looking? Cool feature, right? Historically, I might make a dictionary of forward-looking words. I can find past tense words. I could count. I can make a ratio. You don't need machine learning to count previous words versus forward-looking words, right? You make a ratio. It's kind of simple, right? And that's sort of the one hot encoding NLP world of a decade ago. And even then, it was cool, right? Like that is a real. Like, I actually believe that could have value. And so even though it's simple, it doesn't mean it's not helpful. Uh, Now let's get to the nose touching. All right. Could I have done that 10 years ago? I think I could have. It would have required a lot of investment, right? It would probably be a 6-month vision problem, or maybe it's 3 months. I don't know. That technology was there 10 years ago. And if I really was like, nose touching, this is I'm so confident that that's the best thing, then I could take all my resources and I could put it on nose touching and I can make a feature and study it. The problem with nose touching is that it's a cool idea, but is it worth 6 months of a person's time? Maybe not, right? And what's so cool about this new era of LLMs is that 6 months might become 6 minutes, right? Hey, did they touch their nose? How many times? The profound shift in the ability to study the ideas in your head and the trade-off, the return on your investment, the ROI of these ideas, it's like that investment has been cut by 99% for some tasks. And so all these things that were on your list, the nose touching stuff on your list, that you're, yeah, one day that sounds cool. You have this notebook of stuff that's just too hard. And all of a sudden, you're, well, wait, this isn't too hard. Wait, this isn't too hard anymore. This is great. Um, and so it's an exciting time because it used to be you felt prohibited by the tech. You would chase the things that were technologically within reach because that's a good use of your resources, right? And unless you had very high priors, you couldn't do more, but it was a big decision. And because it's no longer a big decision, it's awesome because it's like, it's kind of like a kid in a candy shop. You're like, I've had all this stuff, and suddenly it's all in front of me. And LLMs has profoundly created this world where you don't need a team anymore. you don't need a giant project to answer basic questions like that, which makes the ability to create these features from either your head, from the moment you think of them to the time you can analyze them, it's just a different world. And so in some ways, it's kind of like a renaissance of feature creation, right? Out of the back of these LLMs.
Can we go through an example in a little bit more detail and talk about some of the kind of technical bits of how you approach these problems?
Look, like today's LLMs are multimodal, so you can give them videos and ask questions, right? So it's almost it's almost unexcitingly untechnical, right? What can you do? I can do a for loop across 1,000 videos and ask how many times did the person touch their nose, and I could put it to a CSV file. I know this is the simplest thing, and then I have the data, and now there we go. So that's almost what's so wild about it. It's like you don't even need to know anything about LLMs to imagine the ability to do this at scale in a new way, and that's what's really changing. Like 5 years ago, I'd have to tell you a diagram for you about how you do this all, but that's what's so profound is almost that it's actually kind of right in front of us.
Clearly a big change is just the introduction of LLMs and your ability to query these historical data sets and create entirely new features, from existing data sets. What else, is evolving in the way you approach things?
It's funny because in some ways everything's changing, and in some ways nothing is changing. And what do I mean by that? As I pointed out earlier, we might have had earlier past tense, present tense ratios, right? We had one of my favorite things there was a lot of dictionary work. I've got a dictionary of uncertainty words. I've got a dictionary of positive words and negative words. And I remember looking at a plot where uncertainty just spiked in the month of May. And I was like, oh, the word May.
Oh, May.
Yeah, yeah. So that tells you how the one hot encoding world can end up in a funny place. So I think the evolution of what's really neat is in that world, you had these sort of the word innovative and creative are just two words that have nothing to do with each other in the old world when I was in school, right? They're just two words floating in space. It's called one hot encoding because it's a big vector and every word exists as a one and a bunch of zeros, right? And you don't know anything about it. And what we've seen is this move to embeddings, which is really neat, where instead of words just kind of existing in isolation of each other, they exist kind of floating in space, like near words that are like them. So cat and dog are kind of similar, and creativity and innovation are kind of similar. And what that lets you do is really generalize your model because now what I learn about creativity, I learn a little bit about innovation, right? Those words kind of coexist in this cloud. So if I learn something about this area of the space, right? If I know what's happening in one quadrant, then I kind of know what's happening in all the words in that quadrant, right? It's hard to think in 300 or 600 dimensions, so I tend to think in three. I'm feeble that way, but that really like was sort of the underpinning of the movement where things started to get more powerful, where you weren't just counting words anymore. And I think what people don't realize is that going back to my syntax versus empirical stuff is that LLMs actually they're starting to add reasoning to them, but certainly as of a year ago, the chat GPT we were all introduced to, it was just trying to imitate humans, right? It wasn't knowledgeable. It didn't say, cats, the dog barks because it knows a dog barks. It said the dog barks because, a logical thing after the word dog is the word barks. And it was wild to feel like these things know about the world when in fact they're just kind of parroting humans in this really interesting way.
This idea of taking advantage of embeddings and kind of the semantic relationship between words as being a big shift in the way you're able to approach problems. Are you getting that kind of for free passively because it's part of this whole LLM world? Like it's part of the way LLMs are built and operate? Or are you like directly, building things around embeddings? Like I remember for a while, clearly it's increasingly popular for organizations to build their own embeddings and to like create embedding spaces for RAG types of applications, that kind of thing. But I remember conversations, like even 5, 6 years ago, maybe I'm thinking of like a interview with Instacart. Like they built an embedding around like groceries and stuff like
Yeah,
that.
right, exactly.
Um,
Everything's a vector.
Everything's a
We're
vector,
all just
exactly.
walking vectors.
And so are there use cases in which you're doing that directly as opposed to, just and
Absolutely.
talk a
Yeah.
little bit about those.
I mean, ultimately, our goal is to make predictions about where, say stocks are going. So, if I'm looking at news stories about a company and I want to make predictions about what that means for that company, right? I guess I have to build a bridge between that news story and some algorithm that's going to make a prediction. And whereas in this one hot world that was there were methods, it is a much more rich world to be able to convert that story into an embedding or multiple embeddings, or there's different ways you could approach that. Once you're in this vector space, it becomes a much more natural connection into the machine learning world, right? If everything's a 300 dimensional vector instead of a blob of words, what comes downstream is and people can imagine is a various sophisticated learning algorithms that can try to tie the thing that you're embedding in whatever creative way you want to into a prediction about the world.
So it's kind of like you were saying before, like you alluded to like same but different. It's like you are doing many of the same things, like sentiment you referenced, maybe related companies, related people, building knowledge graphs, all that kind of stuff. Um, and now, you just have a more powerful way of doing it that is semantically rich as opposed to based on word counts and that kind of thing.
It's more semantically rich, and so those vectors themselves could be features, right? They're you could make features about a company, you can make features about a story, you can make so um and the LLM, I mean, under the hood, it's embedding things, and so if you have access to the internal workings, you can also pull the embedding right out of the process, depending on what the software is. Or you could take the output and do what you embed that, right? You can do so many different. There's so many ways to interact. So I think the very simple way is, hey LLM, give me the sentiment of this thing, and it gives 1 through 10, and like that I could do that. That's very straightforward now. That wouldn't have been straightforward, obviously, years ago. But that's the thing about financial modeling, is that we it is so incredibly noisy, right? In machine learning, I think people don't fully think about the fact that in most machine learning tasks, there is an answer that you could get given the information you have. So if I have to say, "Hey, is this a cat or a dog?" that you could figure out the answer. Usually, "Hey, what should I do in this car? Should I slow down or speed up?" There's usually a good answer. There might be like something crazy happen, so not always. But in finance, you actually you it's not clear that no matter how much information you have, that there is enough information to predict with any real certainty what's going to happen tomorrow, right? And so we're making this prediction into the future, which means that the signal to noise ratio, the noise is just so much bigger, right? And so if we can predict an R squared, and if you see an R squared of like 0.05, something's broken, because that's way too high. Like, you know, like there's no, these things that you're trying to predict are very small signals, right? The nose touching might be real, but it's not going to be predicting most of that stock price. It's going to be a tiny, 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 tiny portion. And so, yeah, that's one of the challenges of the financial markets. And also,
And so from that perspective, the signals that you're operating with are so noisy. The fact that the LLM, the fact that uh the difference between a 5 and a 6 and a 7 sentiment is kind of random, doesn't really matter.
maybe, right? Yeah. Or it matters very, very little in a way that's hard to leverage. It's hard to tell.
And so are we talked a little bit about the hierarchical nature of these signals. I'm curious about how you put that all together. Like I'm envisioning, at a certain point, particularly if you've been doing this for 17 years, like you've collected a crap ton of data. like you're trying to update, a large portfolio of features across that raw data. You're trying to enforce some degree of consistency across that. Like I start to think of like, what platform, what the platform looks like and what the tooling looks like and that kind of stuff to do that at scale.
It's funny. So one thing about Two Sigma is that we call ourselves a platform company because ultimately, it's a very tech heavy investment company. And we have a lot of different teams looking at a lot of different types of data, but they are doing that together into sort of a centralized set of portfolios. Some other financial companies have these competing pods that sort of fight each other, to try to have the best performance. And we're not like that. We're all centralized. So we have a shared platform that kind of we all can feed on. And so what does that look like? We try to break up the investment process into abstractions that have, good APIs, right? So I talked about this model is something that predicts something, but in terms of a platform, right? What does that mean? It means I have a set of inputs, right, which are going to be time-stamped information, and the API. Well, my job is to, send out a prediction for every time cycle, what I think is going to happen to everything that I'm looking at, right? And I'm going to do that in a loop. And so if you provide a modeler with access to data and this API on the output of what they can predict, then their job is to connect the raw data or the features that they've read in to that prediction. And what happens in between those 2 points is sort of the magic of that particular model or the hypothesis or the machine learning or whatever's happening. Obviously, you need a lot of storage. You need good search and a lot of tools to run these back tests are very complicated if you're trying to predict what would happen had I made this decision over the last 15 years on the market. There's a lot of technology that goes into replaying the set of stocks and what would have, creating a virtual world where you're back testing this new idea and see how it would have done. So that's all kind of built into the platform where someone like me, I can just call, okay, here's my forecast. Go tell me how I did. And I can put that I can put that in the platform, and it can come back with the measurements for me without me having to think about how or what or what's happening. So those abstractions are really helpful as because the process of turning raw data into a portfolio has many steps, and my team's responsibility is turning raw data to features, then features to just predictions. And after the predictions, another team is thinking about how to make all those predictions, combine them, and build a portfolio for our company that's going to maximize the returns for our investors.
And so the distinction there is that a prediction that your team is making is whether, well, are you predicting of the future value of features, or are you predicting the future of an equity price based on features? It sounds like there's a line somewhere between one of those things and predicting, the value of the portfolio given a decision to buy or not.
So we're predicting the future price of if we're doing equities, which is where I tend to focus, where I focus and where I work. We are predicting the future price of equities that we trade, but
Based on a feature
based on
set,
all the models
based on
goal is to
everything
turn
you
feature
have.
based
Yeah.
on everything we have, right? Yeah.
Yeah. Yeah. Yeah.
And so our role is to build a bunch of different models. One model might look at CEO interviews. One might look at fundamental prices. One might look at, what an analyst is doing. And so you end up with literally thousands of these models all interacting, and they all have their own view of the world. And the idea is, to keep your signal working, they're hopefully orthogonal enough to one another that when one's not working, and so that's how the company works overall. But the thing is, once you have all these predictions, you can say, all right, overall, we think that this stock price is going up and this stock's price going up. But how do you turn that into a portfolio that doesn't have certain risks, that you're not too exposed to a particular industry, or you're not, so you have to keep everything neutral so that if something happens in the market, we can stay balanced. And so, that's not the part that's called optimization. It's basically converting the predictions into a portfolio that's been optimized to be kind of balanced well. And so that's like its own research area, their own set of researchers, their own set of technology. that then decides what the optimal portfolio we want to be in at that particular time.
I think um, chasing down the signal that I'm latching onto and chasing down here is you kind of anthropomorphize the idea or these models having their own point of view or something along those lines, as you said. Like it made me think of like some kind of agentic extension of that where the models are like arguing with one another about the direction that they think something is going. Is that a thing that you're thinking about?
I mean, if I wasn't, I would. It would be weird, right? I mean, you're hitting the nail on the head. I mean, we have these different views of the world that have been thoughtfully created by people with hypotheses, with views, encapsulating from a set of features. Some might be very interpretable and simple. Some might be more complex in a black box machine learning way. We always have humans on the end to monitor everything, but ultimately we have all these different models with all these different approaches and techniques. And yes, do I think a lot about what an agentic approach to that looks like? Like, absolutely, I do. I'm. It's terrifying and exciting all at once.
Well, what's your best guess today at what an agentic approach to all that looks like or means, even?
My best guess is that you have different agents that have. I mean, this is sort of the point of these agents, right? They have different understanding. They're experts on different things, right? One is in depth, understands currencies, and one understands what the Fed is saying, and I think ultimately their ability to communicate with each other and say, all right, well, I know that this company has, re- you know, I know that interest rates are important for this company. Let me go ask the interest rate expert what's going to happen, and then I'm going to go ask the weather person what's happening tomorrow. And that's this world of these agents making guesses about the things that they're experts on. Yeah, I don't exactly know what it's going to look like, but definitely an area where we're we're experimenting in because it clearly look, any of our roles feel like they're heading towards automation, right? Many, and I don't think just because it's research or innovative, it doesn't mean that a good reasoning LLM can't start to fill in some of those gaps. And I find it, yeah, I find it pretty fascinating, but also exciting because, hey, can I have 10,000 researchers at my fingertips? That would be pretty powerful. And in some ways, it feels like that's the way we're going, and faster than I would have guessed. One thing I'll say is that what I've learned is that innovation cycles seem to be happening pretty quickly at an increased pace. It is business as usual. NLP has always gotten more advanced over the years, but it feels like the cycle is speeding up. And so you need to be ready with a platform that can adapt nimbly to the latest technology, right? So if you're going to go spend a year training up your own thing and then you come out for air and the technology you use that you started a year ago is now obsoleted, that's not going to work. So you really need to be front-footed and look at what's happening in the world and build on top of the ability to take in modern open source approaches or work with vendors and tools that are adapting very quickly. And your platform needs to be able to jump on and off different things at different places to stay up with this new innovation cycle, because there's no time to stop and build something in this space that's going to be able to keep up with what's happening. And so that's kind of fascinating as well.
So interesting. Yeah, you mentioned open source and you kind of started to allude to like how you think about build versus buy. I'm sure it's an oversimplification to say that things are moving too fast for you to build anything.
Right, that's an oversimplification. I think the things that you build need to be plug and playable with the changing world.
Can you give me a concrete example of like
Um,
navigating
so
that?
while there's a lot of interesting things you can do with, say, fine tuning an LLM or something like that, you want to be in a position so that you can swap in the next model, wherever it comes from, however it comes from, very quickly, so that the rest of your stack is not like, oh wait, it's a new model, it's from a new company, everything now has to be redone, right? So you have to design your inputs and outputs so that you can wrap a new model around something such that it's easily ingestible into your system, as opposed to picking something and then customizing on top of that one thing.
Yeah, I'm hearing kind of like the minimum to build is like owning the abstraction,
Right, right. That's
so
minimum.
that you
Yeah,
can swap things out. And then maybe you're selectively, I mean, I've got to imagine that you're, well down the road of fine tuning your own LLMs for in areas that it makes sense. Yes?
yeah, yeah. That which yeah. Obviously, that's an important aspect of it. But even with fine tuning, the things that you had to fine tune 6 months ago, the next model somehow is already, risks being better at the thing you fine tune your 6-month-old model, right? Like, I mean, it's moving that quickly, and so it's kind of wild. You'd think that the level of depth that a generic LLM has on, say, financial accounting statements. I mean, it's incredible. It's in any field, right? We've all seen that. But so maybe I had to fine tune last year's model, but suddenly this year's model seems to have all that ability. So that doesn't mean that you're not fine tuning. It's just that the assumptions that you have about what you need to do might be invalid 6 months down the line as the technology starts to speed up. Is my point.
With that in mind, how do you think about where you make those build investments? Like, um, and I'm specifically trying to get at, it would be easy to say, like, to try to project, well, the LLM is going to be able to do this for us. And in fact, it's not just easy, like, it's necessary in a lot of cases to say, yeah, I'm going to force myself not to go down that rabbit hole because, you know, by the time we're done with X, the LLM is going to be able to do that. But sometimes, you sit around waiting and it doesn't actually fill that gap for you. Like, how do you think about riding that edge?
I mean, it has to do with your priors on how important a particular build is, like how fast you need to get it out, and if you think that you're in a position where you have an edge to utilize that novel thing you're doing, and especially in an industry like finance and quantitative finance, where you're literally competing for prices, it's someone else's machine learning is against your machine learning, and it's a zero sum game, right? So, time matters. If you're 6 months out the gate before the other group, that means that can make a big difference because what you find, by the way, is when you trace signals over time, they get weaker and weaker and weaker as your competition starts to come in, and so it's called alpha
It's kind
decay.
of efficient market.
Yeah, it's an efficient market, right? Any innovation you think you have, well, now everyone has access to data X or Y, and so it slowly decays away over time. So there is a time component, and you have to. It comes back to that return on investment question and your priors as a researcher of how important that particular thing is to get now versus later.
When I think about this, again, this kind of hierarchical, you've got these base level features, you're building higher level features. It made me think a bit of kind of the old ideas, quote unquote, old ideas around like AutoML, like a data robot thing. Like, I'm going to just take all these features and run some statistical programs across them to like combine them in different ways. Like, are you doing a lot of that kind of stuff?
I mean, it's hard not to, right? You're staring at this pile of data. I think it would be, yeah, I wouldn't be doing my job if I haven't explored what happens when I use them all. So yeah, it's a complicated question because the risks of p hacking and overfitting. When you start to take everything at the wall, throw it, and see what sticks, it opens up new scientific rigor questions, and we live or die off of whether we overfit or not, right? If you make that mistake and your model doesn't trade, that's not going to go well for a modeler. You can have you can so we have to be very careful. But if you do it in a rigorous way and careful way, then yeah, I think there's a lot of exciting work to be done in automation end to end, and it's definitely a focus area that we think a lot about and is growing as technology grows.
Yeah, in a lot of ways, it touches on a question that comes up in lots of different spaces around like modular versus end to end. So, for example, um, I've had this conversation with a number of guests in robotics, autonomous vehicles, where like they're the industry has priors of like you've got a sensing system, a control system. You've got these subsystems and you want to wire them together in ways that make sense. But then there are, that's kind of one pole. And the other pole is, well, yeah, let's just take all the
Skip it
data,
all.
feed it
Yeah,
into a
yeah,
model.
right,
And, if we have enough data at some point, the model
totally,
should be able to do it. Like,
right.
is that a tension that you have to?
I mean, yeah, absolutely. It reminds me, yeah, again, back to my days in the PhD program where there was this sort of syntax versus enough data view, and there used to be this competition for who can make the best, uh, machine translation system, and there were all these fancy algorithms. And one day Google entered, and they had the 5-year-old algorithm, but they had this massive model, like 10 times bigger, 100 times bigger than anyone ever had, and they beat everybody. And everyone was like, wait, like we have all these fancy ideas. And like, yeah, but we have a lot of data. And it kind of changed it changed the world. And so I think with enough data, you can start to do really interesting things. And so yes, even I described to you these abstractions. I'm in modeling, and my job is to turn data into forecasts, and then someone else does that. What does the world look like when you just hook raw data up to a portfolio, and you start to take away those abstractions? What new things? And there's definitely a tension there. I think that if you force yourself into a set of chained events, you might lose a lot of the power of machine learning, because at each handoff point, you've stripped things down into your assumption of what matters, and that algorithm might disagree, right? I mean, in fact, machine translation is a great example of that. It used to be voice to text, text to text, text to voice, right? So if I wanted to go from English to Spanish, it would go English, I would say it, it would turn to text, then they would use a back end model, then they would generate. Now it's just them, they don't, that's not how these things work anymore. They've hooked the language, they know how to convert it from audio to audio. It's not running any text in the background. It's an exact example where if somebody had forced that hop, you would actually have a less good system than we have today, when they said, oh, look, let me remove these abstractions that humans have added and just let the system go with enough data. And turns out that can work incredibly well.
Same time, I'm thinking of a conversation I had with Scott Stevenson, who founded a company called DeepGram that's in like the speech to text, text to speech space. And one of the things that he observed is that while skipping, yeah, while staying in the audio domain can be really powerful, sometimes jumping into the text domain is useful, because as us humans, we can't look at the spectrogram and like intuit anything about it. But like text is useful for debugging, like,
Yeah,
and
exactly.
for understanding the system. Are there analogies in your space along those lines?
Yeah, I think interpretability is an interesting thing. And as you go more end to end, you lose more of that visibility into the world, right? And I get asked a lot about how comfortable are we with black boxes in investing, right? When these are big decisions we're making. And what I like to say to people is, well, have you ever gotten under general anesthetic? You say, oh yeah, I mean, when I got my wisdom tooth out or something. It's okay. Did you know that modern science doesn't actually know how that works? We've just tested the inputs, we've tested the outputs, and we've grown comfortable with enough data that general anesthetic has particular properties, and we in medicine are comfortable enough to utilize it by just having very careful measurement on the input and output. And so I love interpretability. I think I'd rather, by the way, have a medicine that people understand. Don't get me wrong. I think that's a more comforting thing, and you'd have higher priors. But if you study something enough, that interpretability maybe isn't as important, and maybe our ability to understand it might not, even if it could be explained, it might be that the thought is so complex that it would be hard to explain even in the most perfect world. And so I tend to prefer interpretability. I have higher priors when I understand what's happening, and if all else being equal, like Occam's razor, simple is better. But that doesn't mean that we should be so naive that we can turn away anything that we don't understand.
At the risk of bouncing all over the place here, I'm remembering you mentioned open source and kind of going back to that platform conversation. I'm curious, like, uh, can you articulate like what you know, like, are you using one of everything, or are there specific? Do you have strong feelings around like, you know, O3 is, the state of the art for us and we're doing everything with XYZ, or we've hard pivoted to Llama 3 and use it for everything, like, or, is the
Yeah.
world.
So, one of the interesting things about these models is, remember how I told you that we're terrified of temporal leakage? timestamps matter. So it is kind of scary for us to use a off the shelf model that's been trained on data in 2020 to ask questions from a document in 2019, right? So if I could say, hey, here's this Enron conference call. Do you think it's good or bad? Is the word Enron going to trigger a negative reaction because somewhere deep in the psyche of the LLM it knows there was a big bankruptcy, and so you have this sort of sneaky look ahead bias that could kind of type in. So in the build versus buy world, there are risks to using these off the shelf things because you can't control the data that's going in, and you might fool yourself. And so that's one reason why we do prefer open source, more controlled experiments, because we know what went in, and we know that what we're seeing we can actually believe in. In terms of the best model, by the time I answer the question, it would probably be different, right? So I guess my quick answer is no. We're not. It's not the kind of thing where I have opinions. This is working now better than that at this task and that task, but nothing that it's clear that this is going to be a iterative process where different there's going to be different advantages to different models. They're going to be hopping over each other. It's going to be happening rapidly, and there's not going to be a horse to bet on. You're going to be well suited to have a diversified set of inputs to build interesting and orthogonal outputs, and you need to be comfortable using a wide array of technologies, not just kind of betting on a single one.
But can you say something to the effect of like, given your preference towards open source and understanding the training environment, data recipe, whatever of a model, you've been able to shift some significant percentage of your workloads to open source models, or conversely, the model yet another feature in this basket of features, and you train all of your data on all of the models, and it's just one level higher that you go to make sense of things.
Yeah, I kind of, if I could snap my fingers and train all my data on all my models with little cost, I think I might. It's nice to have it all there, right? Then I wouldn't have to run any experiments. So I love that concept, and I think actually a colleague of mine last week was framing it basically as combinatorial research, right?
Yeah,
Um,
exactly.
right. The ultimate scary place to go and not get buried. And so I think there's real truth to that. I do think that when you're making a prediction about what's going to happen, much like we have different models that combine to make Two Sigma's forecast about what's happening next, right? The model looking at this data, that data. So too is there value in having an ensemble of LLMs that each have their own strengths and weaknesses. And it's not we, I'm not looking at the best at things. I'm looking for a group of things that each have their own take, that when I average out among them, I'm better off and more robust in the future than had I just picked one. So yeah, I'm not. I really am of the belief that there are pros and cons, and that in itself is a strength because it builds orthogonality, which when you combine orthogonal signals, you get a much smoother response than when they're correlated signals.
And you kind of said something that alluded to, just like, all your data is time stamped, maybe all of your models are time stamped, and you have like a model with a 2019 perspective, or a model with a 2020 perspective, et cetera. Um, are you, and again, speaking of combinatorics, like that explodes really quickly.
It's
Like,
yet another dimension. It's yet just yes another dimension to add to the factorial. Yeah,
yeah.
it's you're exactly right.
And so, but it sounds like you are doing some of that.
Yeah, ultimately, look, we've always done that, right? So if I'm training even a linear model, there's different ways you could do it. If I'm trying to predict the nose touching as a predictor of a company's performance, right? I could, if I take my entire sample and calculate some beta between the number of times they touch and the company performance, then I guaranteed I just overfit my data, and it will work it won't work in the future, but it'll certainly work on the history, right? So what's a better way to do it? The better way to do it is to kind of think about this temporally and say, okay, well, if I had the data from 2000 2010, what would I have done in 2011? And then so those are some small changes you can make to avoid. Now you're still fitting because you still have to be careful. It doesn't solve all your problems, but yeah, we've always lived in a world where you have to be very careful to not get future data in your experiment. And the thing about complex machine learning is if you happen to give it a leak into the future, it will find it. Like a linear regression might not find it, but a neural network that sees, oh, wait a minute, I already know this, it's going to pull whatever weird hole you might have accidentally given it and pull hard and be successful. So I think time is so important.
So what measures do you take to prevent that kind of data leakage?
We're pretty strict about timestamping our data at the company. And so I say all data is a time series. People say, what are you talking about? I'm like, well, every piece of data has a timestamp on it. Well, what do you mean? Yeah, tell me, well, and if you think about it, all data came to exist at some point. And so you can inherently add a timestamp to almost any data. And if you do that, and if you're careful to make that data, that timestamp, the creation date of that data, then you can easily query, hey, I want to join my information, but only backwards in time. And so if you constantly are only looking backwards in time, then you kind of save yourself from that leakage. Now, there are risks because vendors don't always, abide by the same rules. For example, let's say a company wants to track the S&P 500 stocks, and they're going to give me, the website job postings of S&P 500, and they come and they say, oh, I have all this data on the S&P 500. So they give me a 10-year dump. But the problem is, if they gave me a 10-year dump of the S&P 500 today, and then they give me 10 years of history, that has look-ahead bias. Because 10 years ago, we didn't know who the S&P 500 would be in 10 years. So all I have to do is buy all those companies for all 10 years, and I will make a lot of money.
Yeah.
And I think that all I have to do every time someone hires someone, just buy stock, and I would make so much money, right? But it wouldn't be real. It wouldn't generalize to the future. Now, the vendor's not doing this because they're trying to trick you. They just don't think temporally in that same way. And so, you do have to be very vigilant in the timestamps people put in to make sure that leakage doesn't come. Because again, in the world of modern machine learning, that leakage can be, if you think that you have this model that's so performant and you're being tricked, then that's not gonna show up in its live trading, and then you're gonna notice that and eventually turn that off, but it's gonna be a waste of your time.
So thinking about forecasting and predicting the future, what do you predict for the space, and what are you excited about, coming down the road?
I gotta say, I think your question on the agentic stuff is quite exciting. It's hard for all of us in many fields to wrap our head around what's going to happen in the next 6 months to year to 2 years or 5 years down the road. Um, I'm excited about the increase in efficiency that brings and the ability to convert ideas into signals at a faster and faster pace, because then you can just take your most creative people and create data out of them, at such rapid speed, and that's really exciting, and it opens up so many different avenues. And of course, it opens up challenges, right? As these tools and as the LLMs get stronger, if they're able to code as good as your junior engineers, or able to do research as good as your what does that mean for the future of a company like ours and who we hire and training and things like that? So I think that's the challenge, but I think that the upside outweighs some of those challenges, in that the opening up of data is just so profound and exciting that keeps me excited to come to work every day.
Well, Ben, thanks so much for taking the time to jump on and share a bit about what you're up to and what you've learned.
Yeah, I enjoyed it. Thanks for the chat today.
Yeah, thank you.